In this lecture, we're going to be covering header files and object files. So we've briefly discussed how including this header file here gives you access to print functionality and the ability to read data in from the keyboard. Well, we need to be able to create our own header files so that we can share parts of our program with other parts of our program. Or if we wanted to create a library, which we'll get onto later on, we would need a header file to be given to the people who want to use our library so that their compiler knows how to talk with our library. These are all great uses for header files. So essentially, header files, they store definitions and function prototypes. They can store structures as well. Basically, they can store anything that we can store in this file, but the main purpose of header files is to export functionality to someone who will be calling our functions or accessing our library in some way. So yes, in this lecture we won't be creating a library, we'll be creating object files and header files. So let's get to it then. What I want you to do, I want you to create a new file called test.c. Okay, cool. And inside here, we're going to have a void function called myTest. It takes void, no arguments. And we're going to include the stdio header file so we can output to the terminal again. stdio.h. And I just want you to do printf, hello, how are you? And a new line there. Okay, cool. So the question now, how do we access myTest from main.c when they're in completely different files? Well, that's what you would use a header file for. So by making header files, you can share this prototype. So what I want you to do is I want you to create a new file called test.h, h for header, right? And we're going to go in here, we're going to go if and def. Again, we're going to be using the preprocessor here, test underscore h and if. So what does this mean? It says if not defined, compile what's ever between here. So if test underscore h is not defined, compile whatever is under here. And then we just do define test h, so this only happens once. Now what this does is if for whatever reason the same header file was loaded twice, you usually wouldn't want the same code being run twice or three times or being compiled multiple times. It can cause problems in some cases as well, such as like duplicate symbols, stuff like that. So what we do, by using this macro here, it'll only define it once. It'll only run what is in here once. So say we define a structure in here, and I don't know, it has an integer of b, and then we go struct abc. Then this ABC will only be declared once rather than multiple times. Without this, if for some reason the test.h was included more than once in the same compilation process, which could quite easily happen, then it would likely try to define ABC twice, leading it to being defined twice, which isn't legal. So by doing if not def test h, this will run, and then we define test h, and then we know this code will never compile again. It'll only be compiled once, and that's what we want. So you define everything in between here, ideally. Hey, let's get rid of that then. So if we go back to test.c, so we want myTest to be accessible throughout the program, right? So we copy its prototype, we go back to test.h, paste that in. Okay, cool. So now if we want to be able to access this from main.c, we just go to main.c and we go include, double quotes, test.h. And now we can call myTest like that. And this works because what happens is we include test.h when we compile main.c, and that sees that we have this. And if you remember what this means, when you just do this without the curly brackets here, what we're saying to the compiler is, at some point in time you're going to come across this. This is what it looks like, but we're not declaring it here. So anytime we access this, allow the code to compile, because we're going to resolve it later, and I'll tell you where I'll tell you the code to run for this function later on. That's what we say when we do this. When you do this, we say, okay, I want to create a my test function. We know what it looks like now. Run everything in between here. When you say this, we're saying, I know what this function looks like. We don't know what it is yet. Just just allow it to be used, and we'll resolve it later. That's what that says. So when we do this, when you compile test.c, it compiles the my test void here, right? And then when you link the test object and main together, that's when it finally resolves it later. It resolves my test. And we'll explain more about linking shortly. So in here, it's also good practice to include the header file that I tend to put it at the top when you're including something relating to yourself. So it's common practice to include the header file that's associated with your C file. So in this case, we've created a test.h to output things to people who want to include the test functionality, right? But I don't have to include test.h because there's no variables in here or structures I'm going to be using here. But it's good practice to do this anyway, because it matches the prototypes with what you've declared anyway. But it isn't a requirement. You don't have to do it, but it's good practice. Obviously, if you had like structures in here or whatever that you'll be accessing inside this file, then you would have to include it. Right, okay, that was a mouthful. Right, so that's how you create the header file. And now what we're going to do is we're going to actually compile our program, and I'm going to explain the linking process to you. So let's do that now. What we're going to do, go to your Hello World app, and what we're going to do is we are going to open up command prompt, go cd, right click, good, and now we're going to do things a little differently now. Firstly, we're going to compile it the way we have been doing it, just so you can see that there's an error, and I want you to see this error so I can explain it to you. So if you go gcc main.c -o main, and there should be a problem with this. Yes, undefined reference to my test. Okay, now I'm glad this happened, because now I can explain this problem to you. So remember, main includes test.h, and remember I was saying that when we do this without the curlies, we're basically saying to the compiler, allow us to use it and we'll tell you what it is later. Remember? We'll resolve it later, I said. Well, guess what? We didn't resolve it later. So this is the linker complaining that we haven't resolved this, that we said we were going to resolve it, but we never did. That's the linker complaining, right? So undefined reference to my test is because it can't find the code for my test because we haven't told it where it is. So how do you do that? Well, we first need to compile test.c before we compile main.c, because right now we compile only main.c, you see. So you use a different flag in the compiler for this. Do gcc, and then I want you to go -c, and I want you to do test.c, and I want you to go -o test.o. Press enter. Okay, now you can see that what's happened here is it's compiled test.c and it's outputted a file called test.o, which is a compiled object file. And what -c means is it means to create an object file. It means we don't want to create the full program right now. We just want to create a part of it. So create an object file, and we'll do something with that object file later. That's what this means. So if you click on here now, it's going to say it's a binary file. Do you want to open it? I'm going to press yes. You can see that's all the compiled data there, right? So it took test.c, it compiled this function, and it put it into test.o. And right now we don't have a fully complete program because our program is currently composed of an object file. So now we need to link that with main.c, and once we link it with main.c, everything will be resolved. It'll know where my test is and everything. So how do we do that? Well, then we go gcc main.c space test.o space -o main and press enter. And now if you run main, you can see hello, how are you? So let's explain this briefly. This final compile line here, what we say is, okay, we want to compile main.c. You're going to need to look in our test.o object file, the compiled object file. You're going to have to look in there for any dependencies that main.c might have, because we've probably defined them in here. And then that's what we're saying, right? And then one -o main means our output file, you know, main.exe again. So that is how that works, because we tell the compiler, look, if you just do this without the test.o, what, you know, you get the undefined reference again, right? But when you say test.o, it will check test.o's object file to see if this my test symbol is in there, and if it is, it knows the code to run whenever you reference my test. And this is clever stuff, and it also allows you, because of the way object files work, it also allows you to write programs in multiple programming languages and compile them all together anyway. It's quite clever stuff, you know, the link is quite good. So you can have other stuff here too. Let's say we had an object file called abc.o. You would just do that. Hello.o. You would just do that. And what would happen is it would compile main.c, and it would look for symbols in all of these files. That's what would happen. And then finally, -o main gives us our object file, our final running object file, which in our case will be an exe file because we're on Windows. So, you know, that is how header files and object files work. And at some point in this tutorial of this course, we'll be doing libraries, which basically is quite clever. It allows you to share functionality with other programs, but we'll get to that eventually.